Stretching 223 kilometers across the Zambezi River, Lake Kariba is the largest human-created lake by volume in the world. Built in the 1950s, the reservoir is shared by Zambia and Zimbabwe, designed to serve as the primary hydroelectric engine for the entire region. But over the last 2 decades, this colossal body of water has been steadily vanishing. When a structure of this scale begins to fail, it creates a systemic vacuum, pulling apart the economies and ecosystems that depend on it. This graph plots NASA altimetry data along a 20-year timeline, showing a steady drop toward a critical baseline. In December 2022, the water plunged to a historic low, leaving the reservoir with barely 13% of its usable storage. On the ground, this drop exposed miles of sandy shoreline, leaving behind dead trees and a distinct light-colored bathtub ring along the water's edge. A lack of rain creates an obvious water crisis. But to trace the full cascade of this event, we have to look at how a dry spell directly resulted in humans being eaten by desperate predators. This diagram shows a cross-section of Kariba's dam wall. When the reservoir's surface drops below 480 meters, power stations throttle down capacity to avoid damaging intake turbines. Once crossed, turbines grind to a halt, initiating mandatory load shedding. Major cities across both Zambia and Zimbabwe plunged into darkness, enduring daily blackouts that lasted up to 19 hours and crippled local industries. With the region's economic engine stalled, the first domino fell. This infrastructural collapse immediately pushed vulnerable shoreline populations toward desperate measures. The second domino was ecological scarcity. The receding shoreline dried up shallow estuaries, destroying primary breeding grounds for local fish and crocodiles. For lakeside communities facing 90% unemployment, the water is the only source of survival, even as fish stocks heavily deplete. Fishermen resorted to a dangerous behavioral adaptation known as fish driving, venturing in small boats to herd fish into nets in deep, uncharted waters. Starving crocodiles mirrored that desperation. They altered their hunting habits, venturing further out into those same deep waters to raid the human fishing nets. This collision turned fatal. A local fisherman named Siabalimo Chigwambari lost his brother, who was killed by a crocodile while simply trying to pull in his daily catch. His death was not an isolated incident. Crocodiles now account for more than half of all wildlife-related human fatalities in Zimbabwe, heavily clustered around this specific reservoir. The cascade was complete. An El Niño drought decimated the region's power grid, forcing an impoverished population into deeper waters to fight starving predators for dwindling food supplies. Recently, meteorological patterns shifted again. Seasonal rains have returned, slowly raising Kariba's water levels back toward a functional baseline. In response, the Zambezi River Authority allocated 30 billion cubic meters of water to generate power for 2026, waking the grid back up. But the returning water didn't erase the underlying threat. The region realized the danger of remaining entirely at the mercy of volatile El Niño cycles. To solve the human-wildlife conflict, the United Nations Development Program introduced a specific technological intervention, floating cage aquaculture. These $24,000 enclosed pens are anchored offshore. They allow fishermen to safely and sustainably raise tilapia from fingerlings to market size without ever having to physically enter the water. This breaks the climate cascade by severing the direct link between a fisherman's physical safety and the unpredictable volatility of the lake's water levels. Beyond individual fishing pens, governments initiated a macro-level policy solution, launching the Lake Kariba Blue Economy Strategy. Backed by the FAO and the African Development Bank, it is the first shared strategy of its kind designed for a transboundary water body in Africa. The core objective is to intentionally diversify the local economy away from precarious traditional fishing, channeling investments into structured aquaculture, expanding into lakeside ecotourism, and building renewable energy. These structural changes are non-negotiable because the global climate crisis guarantees that severe droughts will inevitably return to the Zambezi Basin. We cannot control the rain. But by understanding the hidden anatomy of a climate cascade, we can engineer resilience, stopping the dominoes from falling before the next crisis hits.